All right. Yeah, it's good enough time. We are in here until 8:30. It was originally 7 o'clock, moved it to 6:30 because they are doing some maintenance work on the AC unit, so I figured people would appreciate having 30 minutes more of AC because it's going to get hot in here by the time we are done, unfortunately. But sorry for if that caused any problems with anyone. Couldn't make it out here. We have the live stream, the recordings available on YouTube. And it's kind of weird having Inception here because my computer is about to show the live stream on the live stream, and that's interesting. But yeah, everything is available at Orlando MLDS on YouTube. So this is Learn to Python Beginner Series Part 2 of 3. We're going to go through functions and classes. Yep. Always love that Python excitement. I don't. Yeah. So before we jump right into it, anyone have any questions before we go on? All right. So best thing to do is open up the Python Interactive Interpreter. That's going to be good enough just to introduce us to functions, and then after that, getting into some of the more advanced parts of functions and classes, we are going to have to start creating and running Python files because we're getting into multi-line code. So, just like last time, if you only have Python 3 installed, all you need is Python. Oh, go ahead.
You mean the terminal, right? Not idle?
Oh, well, you can use either. I would recommend using the terminal because when we get to running our files later, you don't need to open up the terminal then. But yeah, yeah. I'm too used to the terminal, but I know when I was starting learning Python, I used the dev tools that they give you with the Python installs because at that point you don't know any better and you get really comfortable with it, and it's true of any IDE. All right. Yeah, so if you have the idle for Python 3.6 point anything, that's perfect. If you're in the terminal, you only have Python 3 installed. All you need is Python. If you have multiple or you're just not sure, you can do Python 3. And when you open it up, as usual, check the Python version number. This is 3.6.0. I need to update my Anaconda distro because I think they're up to 3.6.2 right now. If you open it up and it looks like this, oh, I don't even have Python 2 installed in this distro. Yeah, if it says Python 2.7 point something in the teens, then especially in this one, things are not going to work exactly as you type them in because we're going to cover things called function annotations. And those were added into Python 3 and not available in Python 2. All right. I'll give people a second who came in to set up just a little bit. Now, when you are programming, if this is the first time that you've really used a programming language, there are times when you will be repeating a lot of code that you write, and we try to deduplicate as much as possible, as long as it doesn't harm readability of our code. And one of the best mechanisms that we have for doing that is called functions. Functions allow us to compartmentalize bits of code that we can just call from anywhere else as long as it is in our namespace, which is a technical term for anything that the code you're currently running is allowed to see. That includes variables, it includes standard library and third-party packages. It includes all your functions, your classes, anything that you import from other packages. And then you can drill further down because technically each function has its own namespace. And we'll get into exactly what that means. But to create our first function, unlike hello world, there's not really a canonical first function, but a pretty easy one is a function that adds a number to another number or prints out something. So in Python, and you'll find this a lot in Python, Python really likes having short, not acronyms, but just we start what we mean and then we cut it off, like the length. There's a function called len in Python, which we talked about last time, which is length, and they just decided, we're going to go to 3, that's good enough. In Python, in other languages, you have things like func in JavaScript. In the .NET family of languages, you have define. No, maybe? Something like that. I know in Arduino C, it's for global variables, things like that. In Python, they use define, and then, like len, they cut it off, so when we declare a function, it's def. Because that's how Python do. So this signifies to the compiler that there's a function coming up, and then we give it a name. So we can just call it my function. You can call it whatever you want. Then we give it. We put parentheses at the end, and we finish off our declaration line with a colon, indicating that we are about to actually write the code that's inside of this function. Now, Python Python does not use brackets. In Python, whitespace is significant. It always is. It drives a lot of programmers coming from other languages insane sometimes, especially if you're coming from a bracket-heavy language like C, Java, JavaScript, even languages like that. But one of the nice things for beginners is that it forces properly indented code, which helps readability out quite a lot. So you can do any kind of indentation that you want. I prefer having 4 spaces. People prefer having tabs. There's a giant war about that, as a lot of people I'm sure are aware. When I'm in here, honestly, any spacing as long as it's consistent is fine. I like just using 2 spaces when I'm in the interactive prompt because it saves a little bit of time than having to do 4 spaces every time. But we indent in, and then we can just type some code. So I'm just going to say, hello there. And in enter, we go to a new line. In the interactive prompt, when you input an empty line, after it's waiting for something, it ends it right there. So we now have a function called myFunction that takes nothing and will print out hello there every single time that it gets called. So just like we had a variable, but now we put our parentheses around it, or we put our parentheses at the end of it, and that signifies, hey, this is a function. We've seen this before with len. I also had range up there before. And we can just call it, and it will run the code that we had inside of our function. And we can call this as many times as we want. It will do the exact same thing every time, as long as nothing has changed. Now, I'm going to go back up. So we're going to go back to this def my function. I'm actually going to call this hello. And now we're going to redefine this function to take a parameter. And our parameter is going to be name. And in our print statement this time, we're actually going to take whatever name this function is given, and we are going to add it to our print statement. Now, in Python 3.5, no, I think it's Python 3.6, they added formatted strings. I'll get to that in just a second. We can do string addition, so I can just say, there's our string. We are physically going to add the name to the end of it, or not physically, whatever. We're just going to put our name on the end of our string. It's going to print that out. Now, when I call the function that we renamed to hello, if I don't give it anything, it's going to say, hey, you didn't give me anything. So I can give it a name. And it will say, hey there, name, hey there, Michael. So we passed it a parameter. It took the parameter from our function definition and used it inside. And we can call this with anything else that we want. And whatever we give it, it will only be able inside of that function. I mentioned namespaces a little bit before. And anything that we declare inside of our function is not available outside of it. So if I try to call name outside of that function, it doesn't know what name is. As a very simplistic, so functions really just are their own self-contained block of code as far as anything that we declare inside of the function. There are things, well, I'll get to that in a bit. Now, what we can do is we can go back up here, and let's say that when we gave hello before, and we didn't give it anything, it errored. Well, if we still want to be able to give it nothing at all and have it still run, what we can do is we can declare a default value for this. And we do that by, we have our def, wondering if I can, no, I don't think I can. Can everyone see the bottom of the screen okay? Okay. So we go back to our function definition, and after our parameter name, we can give it a default value, and for this I can just say you, because if they don't give us a name, like hello there you, still makes sense. So we are saying if I'm not given a name, its default value is the string you. And then the other line just doesn't have to change. We can still do print hello there name. Now, I mentioned formatted strings before. To do a formatted string, we actually just add F for format to the beginning of our string. And what that allows us to do is, well, let me introduce you to a little bit of the historical things. Before this, we had something where we would do .format. We would give it the variable that we want to put into our string, and it would go in there and it would replace this embedded curly brace with the variable value that we gave it. And just to show that this works, I'm just going to do, there's hello Matt. It replaced our curly brace with the variable that we gave it. Oh, and also to show that the empty now works, there's our default value. But going back into here, instead of doing .format and then giving it the variables, this will do a more Swift-like syntax, where we just put F in front of it, and then we can just say insert this variable at this spot. Again, this is only as of Python 3.6. If you're on 3.5, this won't work. And if you're on Python 2, it definitely won't work. So again, hello there, Matt. Formatted strings. It saves us a little bit of time, a little bit of line space, and it's a little bit easier to read in my opinion because the variable that if you have 20 of these and you're inserting them into a long multi-line string, this is way easier to understand. All right. So that's there's a function. It's only printing things right now, but we can pass in a variable, and we can give it a default parameter, or we can give that parameter a default value. Typically, what we use functions for is for returning something. So we can declare, let's say, let's declare a new function that, let's say, add one, and we want to give it some number. And in Python, our return statement is return, and we're going to do num plus 1. Simple as that. Now, if we call add 1 on 3, it returns 4 because we took the number that we gave it. Well, it took the number that we gave it, added 1, and then returned it back to us. Now, we can assign this to a variable. Let's say new num, and then we can do things with that number. Like we can add more to it. When you return something, you can use it. That print statement in here is a little bit doesn't look quite right, or it doesn't act quite how it would when we're running code, because it's still printing. We're still printing things out to the console if we don't actually use it or assign it to a variable. Let's see. Any questions before I go on? I'm going to go into a couple of more advanced things for functions from here.
How does Python know if it's a string or an integer that you have to specify?
So let's take a look at that actually. Okay. So Python is I will keep repeating this because it is an oddball in terms of programming languages. Python is not type safe. There are ways that you can add type checking and type safeness to it, but out of the box, after 20 years, 25 years, Python is not type safe. We can give that function anything that we could anything that we would want. So this hello, if we were to pass it an integer instead of a string, it's not going to say, oh, I was expecting a string. It's actually going to just take the integer and plug it into our string because we just used a format. And the reason why we use format instead of that plus like we were using before is it will take any value that we give it, convert it to what it would look like in a string, and then insert it into the string. So plus 1 for formatting and formatted strings. But even though we said, hey, name, one really isn't a name, it still did it. Where you run into problems is in our add 1, we said num, number. I could give it a string. Or actually, even better, I can give it nothing. Not nothing, but none. And it will just error. Not at the point where you give it the parameter, but where it actually fails executing that line. In here, we are not allowed to add a none type to an int, and it will just fail. There's no type checking. What we can do is, if we really need to, we can actually add our own kind of type checking. So let me go back. Let's do our add 1 function again. There's our num. From last time, we have a function. We can do if type num equals int. You can do that, but the preferred method of doing it in Python is this thing called isInstance. And there's a reason why you can do this. You don't have to give it just num and int. You can actually just, by the way, int is the actual class name. Same thing like none type, or float is the actual float. The string class is str. These are all special. They are reserved. If you use a syntax highlighter in your IDE, every single one of those is going to have a special kind of color to it, specifying that they are important. And we'll actually see that when we open up, when we go from the interactive prompt over to an actual file. But to check the type, we can do if isInstance. If the type of num is the same, well, in this case is int, they're both the same type, then it evaluates, that function returns true. We go into this if statement, and we can return our num plus 1. Or we can do, and then we can add an else statement saying, and then we can use our formatted string here. Num is not, well, I guess a number, because this would work for both integers and floats, technically. Now, if we rerun our add1, we pass in 3. Well, we passed in an integer here. Now that we're doing type checking, if I were to do 3.3, 3.3 is not a number. We only checked for ints. We could add an or statement in there saying if isInstance num int or isInstance num floats or anything like that, then it would work. But this is basic type checking in Python because we don't get it at the function level. We don't get it at the class level either. Now, if you are writing code and you are writing a lot of code, or you know that someone else is going to be reading your code, I highly recommend using a thing called function annotations. This was added into Python 3, and at this point, function annotations don't do much in the base language. They are purely there for readability's sake, for IDEs to look at, for third-party error checkers, and a couple of really interesting uses by third-party libraries. But the native language implementation does not really use them. Now, going back up to our define, we did a type check before for isInstance num int. In Python, function annotations look like that. If I, the programmer, say this function is designed only to take integers, and even though there is no type checking, I want to remind myself and anyone looking at this later on that I designed this function to only take ints. This is how you would do it. We still have our parameter name here. Then we put a colon, and then the class type. Or we can also put in a string that describes what it's supposed to do. That works as well. Additionally, for function annotations, we can also do the return type. So this add1 returns an integer, because when you add you had 1 to an integer, you still have an integer. Or it will also take a string description. So this adds a little bit of inline documentation for all of your parameters that your code can actually go in and inspect. So for the sake of just making this really easy, I'm not going to do the extra type checking, but we have add 1, and I'm just going to put in 1 this time. Our function annotations didn't do a thing. This would be a little more interesting if I just left things as ints, but I can still put in that none type, and the annotations don't do anything. But if we go in and inspect our function, in Python it's dir, and that just gives us a list of all of the different attributes that we can access. That first thing is annotations. And annotations, if we go into add 1, annotations, it is a dictionary where each parameter name, it's a dictionary where the key is the parameter name and also the return if it is given, and then whatever we specified in our function. In this case, we actually the annotations include our string descriptions of what each thing is supposed to be. And when you're working in an IDE, and we'll see this a little bit later, you can hover over any kind of function, and it will in VS Code it actually will give you a little pop-up box that has both these function annotations and the doc string.
So question for you.
Yeah.
In Python, then, your commentary and notation should always happen in line. Is that a true statement, or is it preferred to do it in line? To get the annotation capability here?
When they added annotations in, it is, in my opinion, it is best to use function annotations over instead of putting all of your parameter descriptions in the doc string. And they did actually, in Python 3.6, add inline class type annotations, and we'll get to that a little bit later. But this is preferable to doing inline comments after variable names, or yeah, just doing at param num in your doc string.
Thank you.
Yeah. Oh yeah. So I mentioned doc string. Oh, actually, let me go back to our thing, and so that's one way you can do it. I actually, my preferred way of doing it, and this is purely my opinion, is to just do something like that, and then type out. If you can't figure out what the function is going to do and why it's using each parameter based on the name and the name of each parameter, and then the type that you specify in your annotation, you probably want to make that a smaller function or name things a little better, in my opinion. So this is typically what I do. Now, I mentioned doc strings. A doc string is a little bit of code that, it's a string that we put before we actually write any of the code inside of our function. And what this allows us to do is describe everything that we could possibly want to know about what's going on in this function for inline documentation. So this is a pretty simple one. Add 1 to a given number. And by the way, these quotes here, technically you can do these with just single quotes, or either, yeah, you can have just single ones. In Python, if you put 3, have a string and then 3, you can actually split them off into multi-lines. And just to show that this is the case, actually, no, that kind of failed, but whatever. This allows you to embed other things. If pretty much it will when it sees 3 single or double quotes in a row, it will continue parsing everything that it sees after it as though it is a string until it gets to another set of 3 single or double quotes again. So typically you'll see this for strings that you want to use both single and double quotes inside of the string, or if you want to do multi-line strings.
For this, though, for the doc string, it has to be 3. You couldn't just have
It can, but this is a convention. Yeah, it's just Python best practices to, because most of your doc strings are actually going to be multi-line anyway. And then it's really up to coder preference in a lot of cases as to if you use double or single quotes for your strings and your doc strings, as long as you're consistent. So we'll again do this return num plus 1 to get out of there. And let me double check. Yeah, there we go. So our doc string is available as doc. So just like we had before with our annotations, we can go in. Actually, let's see our annotations again. No, I messed it up. Well, let's see our doc. So there's the doc string that we supplied in the function. And there's our annotations. Notice that when we give it int, it says I recognize this as a the class. So num is supposed to be of class int, and it's returning another thing that is class int.
So for a total beginner, what benefit is this giving you over like a single line comment? Is it for when you're looking at stack trace or something, or for documentation? What benefit is it there other than just looking at a regular comment?
The biggest benefit is that it's able to be used by tools.
Okay.
If you
like PyCharm or something,
yeah,
give you like a type analysis and let you know.
Exactly.
Okay.
Yeah, any kind of program can go in there. IDEs are typically the first thing that people come to mind. You also have programs that can look at all of your functions, look at the doc string and the annotations, and build your documentation for you. And anything in a comment is not included, not given to any program. It really is just ignored by the compiler. So if you put, but if you put your things into annotations and doc strings, those can be used in other programs. And then other questions? Okay, perfect. Yeah, if you want other people to see anything outside of visibly viewing your file, put things into annotations and doc strings. If you only want what you're writing to be viewed by someone who is trying to understand what you wrote, why you wrote your code the way you are, or just to go back and just see what's there. Those are when you put comments in to say, here's what this exact for loop does to this data. If that's not important to how your overall function or your class or your variable is used, then you put it into a comment. If so, if not, put into a doc string of some kind. Sorry, I'm really bad with that. Comments are visible only to you. Anything, any kind of documentation that is not a comment will be visible to programs looking at your code. Yeah, we're pretty much exhausted at this point with what we can do viably inside of the interactive prompt here. The last little thing I want to do is, because Python is not checking your types, we can do things like, well, just to show it off, I can do this def add 1, and let's say we're just going to return num, but we can also return tuples. We can return multiple values. In Python, it's called a tuple. A tuple is just a list that you cannot change. That's really it. It saves. It's good for memory usage. If you know you're not going to change things in a list, use a tuple. But not really important at this point. Data safety. If you're passing something off that other program, if you're writing a library and you're returning data to someone who might not know exactly what's going on in your code, and you don't want that data to be changed, you can return it in a tuple. Yeah. Oh yeah, so just to show it off, if we do add 1, it's not actually going to add 1, but there's our tuple. A tuple in Python is, instead of using brackets, we just use our parentheses, our good old parentheses. This is a tuple. And if I call type, it's not going to be a list. It is type tuple. Yeah, but functions can return more than one value at a time. It just wraps everything into a tuple. Oh, and while we're talking about tuples, we can actually access each individual thing from that. So this if we want to immediately unpack things from tuples, like this add one, a tuple now, we just declare our variables as a tuple, kind of, sorta, not really. But this is the syntax for doing so. It will automatically unpack our values for us. So there's our num, and there's the bool that we passed.
What if you don't know how many items are in the tuple?
Then you can't. Well, oh, actually, that's a very good thing. We'll get into that. Well, yeah. So if this won't work for variable assignment like we just saw here, but if we still want to unpack things, like let's create a list, because we can do this with tuples, we can do this with lists. Whatever, spacing. We print out L. Get this. If we want to unpack everything in there, we can start it off with an asterisk. Oh, can't be used here. Let me think of where we could use this. Try not to pick anything out that's too advanced. Well, in a print statement? That actually would work, yeah. So if we just print out L, it prints a list with our items contained in it. But if we unpack the items before being, technically we unpack before passing it to our print statement, it will print them out individually. Very good. Thanks for that. And actually, before we move on to classes, we can use this in functions, and we typically use this in functions a lot. I'm just going to be really lazy and just do def, unpack. And when we're defining this, we can actually use and we can give a star, and this says I will accept as many arguments as you give me, and I will just put them into a list, or actually, we will put them into a tuple called args for you, so you can access them. And if you wanted to do function annotations, let's say if you knew that it was just all going to be ints, that is proper syntax for declaring a tuple of type int. We can let's continue using our print statement there. We can let's print out the length of args, and we will also go ahead and print everything that gets passed to it. And we will automatically unpack that again, just like we did with our list before. So now if we call unpack with nothing, there's nothing to print out, and we gave it no arguments, so the length of our args is 0. But if I give it, the first value is 1, there's none, this one's true. We gave it 3 things, and then it printed them out for us. This fun story, this is how we can print any arbitrary number of things using the print statement, because it takes in star args. There's while we're on this, we can actually also give it a dictionary with all the things that we want to print out, and we do that by doing a double star. And typically, you will only usually see this when you're dealing with functions. but if and then the canonical things is quargs, and just be lazy, I can just say we know quargs is a dict. Quargs is short for keyword arguments. So think back to a dict. We say here's our key value, and then here's the value associated with that key. What this quargs allow us to do is to take all of the keyword arguments that this function is given, and it puts them into a dictionary for us. And so here I'm actually just going to print our quargs. Now, if we call unpack again, because I didn't bother changing the function name, this won't work, because those are args. Quargs look like this. We specify our keyword arguments by saying here is the argument that I'm explicitly declaring, and it's the parameter name, and then the value that it is associated with. And our double star quargs gets turned into a dictionary. I didn't actually show this before. I should show this. Because I showed default arguments before, but I didn't show multiple. So let's just say, a func, because I'm getting really lazy. Let's just say it takes a number, and then it takes two Boolean values. And the first is defaulted to true, and then the other one I'm calling second, its default value is false. Oh, for proper PEP8 syntax, we actually put spaces around these. So I'm going to print num, and then we're also going to print first, comma, second, and there's a func. Because first and second have default values, I can just call a func on 3, and it will keep our default values. Anything, we can also just say this is going to be false, and I'm going to set this to true. It maintains order. Keyword arguments maintain order if you do not explicitly specify the key that it is given. However, if we didn't even want to bother using first, we just wanted to go straight to second, I could say second equals, and because Python is not type safe, is 4. And so it skips over the first, it assumes the default value, and we only say second equals 4. So we can specify in our functions any number of default parameters that we want to make available to the user, and the user just cherry picks which default value they want to change, and they specify it by using its parameter name equals some value.
Good question.
Yeah.
Earlier you did print star args, and then for keyword args, where it was star star, you did print just KW args. Like you didn't have to use the star.
Yeah. Oh, yes, that's true. I was just showing off the we can unpack things there. I'm forgetting offhand when you would want to unpack a dictionary. I've used it before, but I can't think of anything off the top of my head. So we can do things out of order. Let's see how we're doing on time. I have an hour left. I'm going to just quickly show off the most generic function you could possibly make. And when I say that, I really do mean it. I'm going to write over a func, And we're going to say this is going to take any number of args and any number of quargs. And here's the fun thing. This syntax for args, quargs, we can put anything that this function will use, and then it will just say, hey, I'm going to also accept anything else that the code gives me. And I'm just going to pass everything on through to the print statement. Oh, duh, what am I thinking? This is actually when you'd want to use to unpack keyword arguments, because then they get unpacked, you know, key equals value, so on and so on. And so you usually see it being passed into a function. That's usually the only time you'll ever see a dictionary unpacked like that. So to put it bluntly, I have renamed the print statement by merely just applying a wrapper around it. And actually, to make that even better, I'm just going to say f length of args. Oh, and actually, we don't even need a formatted string there because I can just do this. And then pass everything into the print statement. So I've just applied a wrapper to this print statement here. And if we call a func with nothing in it, length of args 0, and then we call the print statement which prints out nothing. We can also just give it 1, 2, 3, 4, length of args 4, and then it prints out those 4 things. Can also say this equals true. Oh, this is, I think this is specified somewhere. Let's try that again. Name is a Java keyword. I'm not sure what I'm doing wrong on there.
I got the same error myself when I tried to do the print with star KWRs. So it
Okay.
seems to work without the star.
Oh, wait a second. Oh, is an invalid keyword function. Print doesn't take quargs. That's why. I could, well, let's do this. Let's just, it takes that, let's just print out length of quargs instead, and then only pass in the args. I guess the print statement doesn't take arbitrary keyword arguments, but we can. And then just pass in args. So we go back to our afunc. We were given 1 quarg, and then we just pass in the args. So it's a pass-through function. We're just intercepting all of the keyword arguments. So that was a little more complicated than I thought I was going to get into with args and quargs. All right. We have a little under an hour. A lot of what we just went through with functions is a lot where that's going to make a lot more sense when we actually start typing things into files. And we're going to be using a lot of this in classes. Classes don't add too terribly much more to functions. Or you know functions, you know a lot of what we're going to be doing in classes. So I'm going to go ahead and quit there. And in editor, I'm going to create a new Python file. And, well, let me go ahead and save this so I can get my Python syntax. Classes.py, and there we go. My syntax highlighter is now using Python. And just to show that, yep, there we go. So now I have my code completion. I'll do my hello world because in a file. I'll go ahead and save it. I'll make this smaller. And like we did last time, to run a file, you do Python, and then as long as you're in the same directory folder as your Python file, you just give it the name, and it runs. But we now have syntax highlighting, so we can see all of that awesome syntax highlighting when we go ahead and create our file. Let's get a better look at our print statement, or our functions. So let's go ahead and do that add one again. It takes a number with type int, and it returns an int. We have a docstring, returns the given number with 1 added to it, return num plus 1. Code is so much more legible when you have a syntax highlighter. It really, really is. Then, we've declared a function. We can go ahead and run it in the same code by doing add one like we had before. Just going to give it the number 1, resave it, rerun it. Now, if we were in the interactive prompt, it would have printed out, or it would have looked like it printed out into our prompt, but that's just returning into the void because we're not in our interactive prompt anymore. If we want to get anything out into the console, we have to wrap it in a print statement. And there we go. There's our output. And now that we're in our file, we can do some more interesting things because we don't have to worry about, well, multi-line things are hard to do for long periods of time in the interactive prompt, not so in a file. So let's do add one to everything. So this is a function called add one to everything, and we can see by it takes a list. So even if we didn't have a type annotation, it takes a list. But with our type annotation, we can see it expects a list of type int. Or if you don't want to do that, we could just say it's a list. Or we could still do our string description, a list of ints, whatever you want to do, because that only gets shown to other developers and does not actually affect our code. The way that I like to do that is that, and we return the same thing as well. Oh, and so it is good to add doc strings to everything. For the sake of making things a little faster, I'm not going to add doc strings to everything. So let's do a for loop, because now we don't have to worry about indenting everything in the IDE or in the interactive prompt. Here is this for I in range len thing that we had before. Again, I is just going to be the index, an index for every item in the list. There are more elegant ways to do what we're about to do, but let's use a for loop because now we are in our file. So we can overwrite everything in there. So and we can also use our plus equals from before. So a list plus equals 1, and then we have to return a list. So going back, now going into our print statement, we can do add one to everything, and we can use auto completion because yay IDEs. Or this isn't even an IDE; it's a text editor. Here's a list with 1, 2, 3, 4 in it. Adds one to everything. And you don't have, oh, and again, now that we're in our file, we can do my list equals that, and pass in my list, same thing. All right. So, perfect.
How would you keep the Python window from closing instantly when you run this?
So you're using the idle, I believe.
I just tried to run it from Explorer, and I know that like C++, you can do a thing that keeps it from closing the window.
I would recommend. Actually, there is a way to do it. You can. I don't know if we touched on this last time. There's a little hack that you can do. There's a function called input that waits for any kind of input. You can give it a prompt, but if you just want to pause code execution for debug purposes or kind of see what all the print statements were when you run something, you can use input and it will pause it just to show what that looks like. It's waiting for me to enter in something, and it pauses code execution. So if you find that whatever way that you feel most comfortable running your code is just running it and then closing it, you can add input to the end of your program. And enter, that's our input. Simple as that. Typically, actually, we can use that. So let's see, we had add one before. If we wanted to write something to use these functions, we could actually say my num. Let's do let's just call it number. Number equals input. Give me a number. And then we can do our print, add one, convert to an int. We're not doing any type checking. If we give this S, it will fail, but for the sake of just kind of showing it, give me a number, 6. Added 1 to it and printed it out to the console. But, again, give me a number, I. It assumes that we're using I, and it can't convert I into an integer, can't convert it into a number. All right. So, let's get into classes. We have some functions. We even have a little bit of a main main execution. I'm going to open up a new file here. So I'm going to actually call this one class. Yeah, I guess class.py. So in Python, so Python is an object-oriented language. What that means is that we can use our code to model things as though they are an object. They are an item. An item has attributes. It also, so this, an intro, and we'll do this here, is something like a shape. A shape has some volume. Maybe it has some sides to it. And then we can do things to that. We can say move it from here to here. We can compute certain things on it. We can compare different objects to each other. And those are our methods. When a function is attached to a class, it's called a method. And when a variable is attached to a class, it's called an attribute. Just how it is. They're the same thing. You just call them different things when you're talking to other programmers. So in Python, for a class, we actually don't shorten anything because I guess define was 6 characters is too long, but 5 is still short enough. So when we declare a new class, we say class, and we call it something. So going with our shape analogy, or our shape idea, we're going to say class shape. And then even classes also have docstrings to them. And you would give way more information than that, but for the sake of just getting through things. Class shape is a shape object. A class has certain, a shape has certain attributes like the number of sides. And let's actually do this. So the shape would be a meta class in our case. We don't know how many sides a shape has, so we can just give it a default value none. In the modern 3.6 syntax, we actually can just do that. This is new as of Python 3.6. It allows us to add a type annotation to class attributes. And that's all it is. If we wanted to give this a default value, it would just look like that, or that, or whatever we want it to do. So a shape has sides, and maybe we would, no, actually, let's do this. And we're going to give it a method called getArea. I'm just going to type all of this out. Actually, this is going to return a float because we're going to compute things, I suppose. Actually, I'm not going to get into that. I'm just going to say pass. Pass just says, I don't do anything on this line. Just don't do anything. So this is our very basic shape object. It has an uninstantiated attribute called sides, and it has a function, or it has a method called getArea that we will use to calculate the shape's area based on its type and the sides that it has. I think that might just be a little too complicated for this particular one. Yeah, we'll just leave it at that for now. So, I talked about this in our class. Our method looks very similar to what we were doing with functions. The only difference is that we have to pass in this first argument here called self. We are not required to call it self. However, this is another Python convention. You just call it self. I could change this to be an emoji if I wanted to. Python doesn't care. Python 3 is completely Unicode compliant, so you can call things emojis. Just like Swift, because everyone loves doing things with emojis. Actually, when you're doing a lot of mathematics, one of the first things I do is the Unicode symbol for pi, or pi theta equals math.pi, math.theta. So your calculations look a little more legible in your code, but I digress. if we were, so yeah, we have this class shape, and when we want to do a shape, we just instantiate it, just like that. There's another Python convention for capitalizing things. Classes you capitalize. Functions are not capitalized. Any variables are not capitalized. Things like that. So if you are typing something in and it has a capital, you can be fairly confident that it is a class. If it starts like this, if it looks like that, you can be fairly confident that it is a function. It just makes your code that much easier to understand when you keep to conventions like that, but you are technically allowed to name it whatever you want. The only exceptions to the class rule are things like int, float, string, built-in classes. And finally, so we've created a shape object, and we can just print that out. And if we run this, we get this lovely looking syntax here. We create a shape object, and at main, which this is the name of the file that we are technically running. This main just means this is the file that we're running. It's not actually the name of the file, class.py. But this is a shape object at this location in memory. This looks terrible, doesn't it? So what we can do is we can use, well, this looks terrible, but notice we only declared, we have sides and we have getArea as a method. If instead of just printing a shape, we print dir, remember dir prints out all of the attributes that are associated with that thing, we get a lot for free. Look at all of these amazing methods that we did not define that we get. Included, we get our doc like we had before. We have init, which is actually what gets called when we initialize an object. I'll look at that next. String representation. Here's our annotations again. If we implement this, it calculates, well, whenever a greater than is called on our object, it calls this. Not equals to, things like that. So we get a lot, because what it is implicitly doing when it creates this is, whether or not we do this, everything inherits from the base object in Python. Everything in Python is an object, and this is actually the class shape object is the preferred way of doing this, even though it does the object on its own. This is how we specify class inheritance. And class inheritance, any child object, any child class, automatically gains any of the attributes and methods of what it is inheriting from, parent, child. So we have this class, and I'm actually just going to say none because actually, let's do this class. So if we have a square is a child class of shape. It is a type of shape. And in here, we can specify explicitly that sides equals 4, and we can still put in our type annotation there. Now, instead of doing a shape, we can do square equals square. And let's go ahead and print out a square. So we have a square object at that point in memory. How many sides does it have? It has 4 sides. Now this main square object at memory looks just really bad. So what we can do is, looking at all of these methods that we get out of the box, it's kind of cut off here actually. I'm just going to change that a little bit. Let's do our deer again on our square, actually. Yeah, that's better. So we have this one right here, this ERPR right here, and that is short for representation. And that is actually what's being called when we print out the representation of our object to the console. So if we overwrite over here, I'm actually just going to get rid of this get area. Representation. It gets passed self and no arguments. Now, and it returns a string, going with our function annotations here. Anything that we return from this is going to be printed out into the console. So to make it look really nice, we can, actually I'm going to replace that with 0 up there. It'll make sense in a second. We're going to print out a formatted string that says a something with something sides. Now, this first one is going to be a little more understandable. So with something sides, here's where we use our self, because self is, when we pass in self, it gets given whatever that object is. So within our representation function, if we want to get the number of sides that our current object has, we do self.sides. Pretty simple. This is how inside of our class and inside of our function we can access the different attributes and functions that are also given in that class. Now this other one over here, a blank with some number of sides, we're actually going to do self._, is it name? Yeah. Let's see. I think my autocomplete might just be messing with me. So let's see if this works. So what this should do is print a square with 4 sides when we rerun this. Or actually, I need to get rid of deer. And if not, I know how to fix it. Yeah, square object has no attribute name, so there. That should work. A square with 4 sides. What basic thing that I just did here is there's a higher level kind of class that has metadata about the class itself and not just the object that we have instantiated, and that's how I'm just pulling the name of the class out of it. But this a square with 4 sides looks much better than main shape at place in memory. It is way more readable. And notice that we're not because square is a child object of shape, and we only overwrote the representation in shape. Anything that extends, anything that inherits from shape is going to get that representation. So we can also do, and I'll put it up here to order it by sides. I can do class triangle. It inherits from shape. A triangle. And again, these are not needed, but they help with readability when you fill them out. a triangle has 3 sides. So now I'm actually just going to say is a shape and then give it different things. Print a shape. We rerun this, and it has a triangle with 3 sides. Any questions? This is a fast introduction to classes. Awesome. All right. So Python does support multiple inheritance. This is there's also an area of debate, but it absolutely does. And it's the order that you do your multiple inheritance from is critical, because if you it will prefer whatever comes after, because it will inherit things in a row. So if you were so if we had a triangle and we technically this is entirely allowed, even though it's redundant. Shape already inherits from object. Everything inherits from object. But we can explicitly do triangle, object, shape, and we get everything anyway. However, if we do this, we first inherit from shape, and then we inherit from object. Because we inherit from object after we define our new, better-looking representation, if we rerun this code, it should revert. It should have reverted. I thought it would have reverted. I guess it's probably just something specific with object, but anything shared will be overwritten in the order that it inherits from. Typically, I see a lot of people would prefer to do, instead of multiple inheritance, we'll do instantiating objects embedded as class attributes. So let's actually do let's add an init. So part of that long list of things was our initialization function, which takes nothing and does nothing as far as we are concerned. Now, if I want to say, when I declare a shape, we have to give it an XY position in a coordinate plane. We overwrite our initializer. We first have to give it self. Then we can give it our, we expect to have an X and Y. So init a shape with coordinates. And then we just say self.x equals x and self.y equals y. So because we do this in shape, we get this in triangle and square. And now this code isn't going to work anymore because we are not passing anything to our initializer, and our triangle expects us to give an x and y coordinate. So we can just say this is going to be at 1, 2. And we're back. Now that we have these, we can actually go ahead, actually, before I do that, let's A shape and the also named B shape is another triangle, and it's going to be a 3, 4. So let's print out B shape. Rerun this. Now they're both saying a triangle with 3 sides. Well, that three sides is not really important to us because we can infer the number of sides based on our class name. That doesn't really help us in distinguishing these two objects. So what we can do instead is go back up to our representation, and instead of doing a name with some number of sides, we can do a name at x equals y equals, and we can pass in Actually, not even, that's not even, let's do it better. At da-da, da-da, that's going to look better. So self.y, self.x, rerun. That's a little more useful to us. So these are two separate objects with their own information. They technically do share the same value for size because we have done nothing to change that. And given the class and what we expect to do with it, we really shouldn't need to anyway. However, we've specified that these are at two different locations, and each object is its own object with its own attributes and, well, with its own attributes in this case. So let's go ahead and give this its first actual function that's not just given to it. Let's calculate distance. So we first need to do self. However, we're also going to give this a different shape. So we can compare the distance between this, whatever shape the method is attached to, with some other shape. Now, there's this odd thing when doing class methods that work on themselves. I prefer to just do something like that, because if we just tried to do this, we'll get a syntax error, because while we are defining our class doesn't actually exist yet, and so it doesn't know what shape is. But we can still just give it strings. So when you're reading this, hey, this method on our shape object expects another shape. It's just kind of a workaround for that. And it's going to return a float, because we can't always be sure that it's going to give us an integer when calculating distance. So basic distance formula. Let's actually pull out the other let's do x1, y1 equals self.x and self.y, and then we can pull out x2 and y2 equals shape.x and shape.y. And we'll just do this. Dist equals, I have to remember my math here, triangulation. Oh, right. So we have to do some math on this. There is not a native square root function. If you remember back to trigonometry, we need to take the square root of the difference in our locations, squared minus each other, get to it. So we're actually going to have to import math. And this is how we import packages in Python. We just say import, and that's the package that we want to import. And down here, we can, to get our square root function out of it, we do math dot square root. And we actually need to do the, yeah, we don't even need that. x1 minus x2 squared. It's plus, isn't it? I think. We'll see in a second. y1 minus y2 squared. Double check that. Yeah, there we go. And return our distance. And I'm sure if I'm not right, some mathematician on the internet is laughing at me somewhere. Let's give this a good doc string. Returns the distance between two shapes, or between this and a given shape. Between two shapes implies that we're expecting to be given two different shapes in that function. Semantics, however you want to describe it. So let's go ahead and try this out. I'm going to go ahead, well, no, we'll keep that in there because it's telling us our position so we can visually check to see if that's working. We'll go ahead and print a shape and compare, get the distance from B shape. Cross my fingers and hope it doesn't break. That looks roughly like it should. I think that actually works. Let's double check that. Let's put this one at the origin. And we're going to put this one exactly one thing away from it. And if it spits out one, fairly certain it's right. There we go. Cool. Put that back over. All right. So that's pretty cool. We have a triangle, square. We have this base object here. Let me hide that so we can see more things. Yeah. Any questions? Anything anyone wants to call me out on? Anything that you want to see that I haven't shown already? All right. And
I have a question. If you wanted to import just the square root function itself.
I was just about to do that because yeah, we can do exactly that in Python. So instead of import math, if we just want to grab one or a couple of things out of it, we do from math import square root, and then back down here because it doesn't know what the heck math is, but it knows what square root is. We just change that here. If you only need to grab one thing out of there, that's perfect. If you are grabbing things from different sources that have the same name, can't really do, well, you can only do that to one. You would still have to do that, or say that we don't like this this shorthand for square root. We can actually do as and just change the name of whatever we want it to be in this file. So from math import as square root. Yeah.
What happens if the same name is used for a method within two different classes?
That's actually a good question. So let's say we if you have two different classes and they're completely separate, then it doesn't really matter. If we have one class that inherits from one, the child class, if it overwrites anything, it overwrites whatever was there. We can already see that. We've already done that twice with this init and representation. These already existed for us, and we just completely overwrote what was there. We completely overwrote what was there and said, I don't care what was there before, we're just going to overwrite our representation to be this more interesting string that's more useful to us.
Now as you said, you keep saying that Python isn't Whitespace. So if on one of these methods, you could put whatever you define whatever you want.
Exactly.
What happens if you didn't want that class? Does Python just try to do the best it can?
Python will always try to do the best it can with whatever you give it, and if you give it something that it doesn't expect, then it will just error. It will let you know. For example, on this, let's just say this representation. Let's just comment that out, and in our shape class, we're just going to say our representation equals true. We can do that. Now, if we try to run this, a Boolean object is not callable because it expects that representation is a function. So it will Python will chug along and do its best, but when it runs into an error, because the computer will do no more or less exactly what you tell it to, and it will just fail if it knows that, if it thinks that you've screwed up in some way. But that is totally allowable. We can overwrite functions with variables. We can overwrite functions with classes. We can overwrite anything with anything. It doesn't care until we try to run it.
Yeah, the reason I was asking because some languages like C++, the methods have a different syntax than the dot syntax. We have dot, so you have to use the path. It can only be used with objects of that class.
Oh,
Python,
yeah.
uses function syntax with a parenthesis. So you could use class method or function, whatever it's called, put anything inside it. And Python doesn't check the type to make sure it really belongs to that class.
Yeah. So here's another fun thing about Python. It's not even another fun thing. I've been saying it this whole time. Everything in Python is an object. Even functions are objects. So instead of calling a shape distance and giving another shape, if we just print it, let's go back and fix this. There we go. This is a object. Well, our function is an object, which is a bound method distance of a triangle at whatever, because that's our representation. But our class method is an object associated with another object that is callable. It's kind of weird.
So, if I can expound on this question here, if I'm looking at, say I have shape as my master class, right?
Mm-hmm.
Say I have two other class files. One is circle, one is square. And both of them have a method called getArea. If I want to, in my program, call circles getArea, and then later on call squares getArea, how would I do that? Would that be a dot syntax similar to Java and C++, or would that be something different?
It would be a dot syntax. Let's actually do that. Am I on time? 8:22. We can still be in here until 9 o'clock if you guys want to do that. Is the temperature all right with everyone? I don't see any shaking heads. Let's actually go ahead and implement our area, because I can show off two important class things, things that we use with classes for implementing that. So the first thing that we can do, well, we already have our initializer up here, but if we don't know what our shape is, we can't really compute our area. However, we still want to say every shape should have an area to it, unless it's a line, but a line really isn't a shape, it's just kind of a line. So what we can do is we can say, because we're going to compute it, it is a function, we're just going to call it area, and doesn't take anything, and it's going to return a float. Now, if we in Python, if we have there's a handful of built-in errors, and one of them that we would use in this particular use case is called not implemented, because every shape should have an area, and in our base class we can say you should implement an area function yourself, because I'm a shape. I don't know what shape you are. I don't know how to calculate it. So we can so if this gets called either on the parent class or a child class that has not yet implemented the area function, there we go, not implemented, we can just have it raise this not implemented error, and our code will say, hey, I ran into an error, I'm going to quit now. But here's this odd thing. This area is not really a function. Functions imply that we do something. Area looks more like an attribute of a shape. But we still need to compute it. And we don't need to take in anything except from what the shape already has in order to compute it. So what we can do is use something in Python called a decorator. And this particular one is property. And what this allows us to do is create a function that takes nothing except a way to grab things about the object itself and returns something, calculates something and then returns it. And property takes that function and just removes the parentheses from the end of it. So from from the programmer's point of view, when you're actually using this class, shape just looks like any other attribute, even though on the back end it's calculating everything. And these Python function decorators, they just take some function, do something to it, and overwrite it. It's just it's a shorthand for that. But what this allows us to do is go into our triangle and actually implement. Let's actually do this in square first, because we can use this triangle to actually show the error later. So same thing. It's a property called area. It's going to return a float. And when we overwrite things, when we overwrite methods, it overwrites doc strings, so we give it a new doc string. Area of the square. Return self dot side length. Square. So that's our entire area function slash property slash attribute, but it has no idea what side length is because we haven't asked for it. All we have is a shape that is out of position. And this isn't really something that we can, we can't really just add side length over into our shape object. A circle doesn't have a side length. It has a radius. And that's how we can compute area. So what we need to do is go into our square, and we're going to overwrite our initializer. That's our del adder. Our initializer. So it can so that it can take our coordinates once again, but it can also take side length. And by the way, we can call these whatever you want. This self.x equals x. You can call them whatever you want on either side. Doesn't really matter. And let's just say that this can be a float. And what we can actually do here is instead of copying this self.x and self.y, we can just call our parent class directly and call its initializer and pass in the things that it needs. And then we can do self.side length equals side length. So we can, we don't have to copy the code every single time. And this is especially good if you're doing computations or something complicated in your parent class. You don't have to call it over again. But now we have everything that we need in order to calculate our area. So I'm going to go ahead and comment this stuff out and just do square down here. Variable name, lowercase. Class, uppercase. Looks nice. It's going to be at position 1 and 2, and we're going to give it a side length of 4. Now, if this works properly, when we print, notice square.area, we created it as a method, but because we put property, we don't have to do that. It just looks like an attribute, but it calculates it for us. So we go ahead and run this with side length of 4 squared, we should get 16. Ta-da! So fairly simple. Let's continue this. Just let's add a new shape. We're going to call this one circle. And it also takes some shape. Now, when we had our triangle and square classes, we said, a triangle has 3 sides, a square has 4 sides. You could argue that a circle either has 1 or 0 sides to it. I don't really mind, but we said sides up here equals 0 for the sake of this. We don't even, we can just say, oh, I'm fine with that circle thing having 0 sides, like we have in our shape object. So all I'm going to do is just keep the same sides, and I'm going to go into my init. I'm going to call self again. I'm going to take in my x and my y. This is also an int. But now, instead of doing sides, side length, I'm going to take my, I'm going to accept a radius, which can be a float, it can be an int, whatever you want. We're going to call our super again. Initialize our parent class with its x and y. And then we're also going to set our, the circle's radius to be the radius that it is given. And then when we go down here and we do our property, our area, to create our area, let's see. Here's the circle. We return, and pi, from math, import square root pi, because we need to get that. Because for circles, our radius is determined by pi times our radius squared. Save that. We can keep our square there. We're going to create a new circle. It's going to be all the way over at 4, 8, and it has a radius of 1.1. Oh, wait a second. There we go. We're going to let's actually go up here. We're going to print our square. And we're going to print out the number of sides that our square has. And we're going to do the same thing down here, the exact same. There we go. So there's our square. Square has 4 sides. It has an area of 16. Then we have a circle with 0 sides, and there's our area for a square of radius 1.1. And then just kind of continuing our little print, because we now have 2 objects once again. We can call our circle and determine our distance from the square. And it's that far away. Now, we're duplicating a bit of code here. So, because we just want, we're just going to print out the representation, the sides, and the area the whole time. And because they both implement, or they're both the same shape, they have the same things, we can just put that into a for loop. So I can just say for shape in, and then we don't even have to give them variable names. We can just say, I'm going to instantiate a shape, and I'm going to instantiate a circle inside of this thing. And then inside this for loop, instead of square, it's just shape. And then shape.sides, shape.area. Oh, we don't, yeah, because of the distance. Ta-da. Classes that are not the same, but they share the same methods because they come from a common parent class. We can call the same things on them. And just to show off this last little bit from before, we still have this lonely triangle, and it didn't implement its area property. Let's just kind of show off. We're going to create a triangle at 0, 0, and we want it to print its area. Oh, well, we haven't implemented that yet, so code doesn't know what to do. We error out, and that's that. One other little bit when you're working with classes, another good one of these decorators to know is I'm not going to give it a proper thing, but this static method. If you want to attach a function, I'll go back to our hello thing and our name. Notice that with a static method, it's just going to print it. With a static method, static methods do not take self because they are a static method. They do not need any information from the class, and but we can still attach them as a bound method to the class. Yeah, I think we'll just kind of do that. So if I just want to call instead of printing that out, let's go ahead and just do this. So instantiating a triangle, and then I have my hello static method that's attached to my try. Oh, did I do that? Which one did I do that in? I did that in square. I'm going to go ahead and move this out. Let's just move it into shape. There we go. So, ta-da! Hello, Michael. This is good if you're doing things like mathematics, or it's really good for anything if you just are doing calculations and you don't want to make a global function, but you also don't need anything that comes from the class, so you don't need to supply self. And, one of the nice things is anything that you declare as a static method can be run from an uninstantiated object. So instead of down here doing try.hello, I can just do this. I don't even have to instantiate this object. It just has a function called hello. I think it's pretty cool. So, let's see. It is 8:39. Let me show you just one quick thing. We have all of this run code down in here, but let's say we have imports up here. If we wanted to use these shape files from another file, And we still wanted to have this kind of code down here for debugging purposes, testing, things like that. There are better ways to do this, and I will actually show a library that makes this look much nicer next month. But if we only want this code to run when we explicitly run this file, what we can do is add this line, and it looks really ugly, I know. If name equals main, run this stuff. And that is how we get code that if we run this file directly, it will run this code, but if we import it from somewhere else, it won't. That's just what it looks like. It's pretty ugly, but it works. So if we, again, if we run this class.py function directly, it runs our code. But let's say we go back over to classes, and, well, I'll keep that there. Let's go up here, and I'm in the same directory, so what I can do is I can import, let's change the name of this file to something that actually makes sense. We're going to call this shapes.py. So back in our thing over here, I can do import shapes. So let's repurpose this. Let's do input, give me a number. And with the number that we give it, we can actually print out an instantiated shape.circle. Let's just do it at origin because we don't want that information. But we can put the number as our radius and then print out the area. So if I go into, because it was called classes.py, give me a number, 2. Shapes. I imported shapes. Oh, and we need to convert it to an integer. Oh, it overwrote my thing. There we go. Sometimes text editors can be not so helpful. There we go. That doesn't look right to me, but whatever, we're just showing off the imports. That might be right. Yeah, so notice when we imported our code here, it didn't run all that test code. If we go back in here, we comment out this line, and we need to unindent this because we are not in a block anymore. If we rerun this, it runs all of our things before we actually get to our the code that we had there before. Give me a number 2. Ta-da! So yeah, there we go. Classes, give me a number 1. Yeah, okay, yeah, it works. So that's a lot of information. I am going to post this shapes file. I don't think we showed off anything, or I don't think we showed off anything in functions that we have in here that isn't in shapes. Yeah, I will post a link to this in the meetup event. It'll be on the OPUG repo. Any questions on this or next month? PyCon. Oh yeah, PyCon's happening. I didn't mention that. October 7th, Florida PyCon, here in the Exchange building. Yeah, I think that's it. All right.
Yeah. I guess
Sure.